Okay, last topic for this week's class is real and apparent limits. As I talked about in the orientation session that we had, stats is about concepts. The math isn't super difficult, but sometimes the concepts are a little tricky. And real and apparent limits is one of those concepts that's how I put it, interesting. Okay, let's say I measure the time it takes a sample of 87 people to run 400 meters. And I have the participants and I have their times, the person with the fastest time on down to the person with the slowest time. And on your left on the screen, you can see the participant and the number of seconds to run 400 meters. And the fastest time was 50.4 seconds. Now the stopwatch that I recorded this on was accurate to the 10th of a second. So my unit of measure, in terms of the lowest unit of measure, is the 10th of a second, which is 0.1 of a second. Now I have to think that my stopwatch is to the 10th of a second, so what does 50.4 seconds represent as a 10th of a second? And when I think of it, it is measured in terms of the apparent limit at the 50.4. But the real limits of 50.4 extend from 50.35 to 50.45. So if in real time, in terms of if this thing's accurate, if the time is 50.36 or 37, it should round up to 50.4. If the time is 50.44 or 50.43, it should round down to 50.4 seconds. That would have my stopwatch most accurate for a 10th of a second in terms of my level of accuracy. Now, in terms of looking at it this way, 50.35 has to be an imaginary border between 50.4 and 50.3, because what do I do if the time is actually 50.35 exactly? Do I round up? Do I round down? Well, I have to look at it this way. That's kind of like an imaginary breaking point or border. It's kind of like an unreal border. Examples in the real world. This is where I live. That's my property that I live on. We have 100 acres. The red line on this Google Map image is the border between our property and our neighbor's property to the south. That line is an imaginary line. I can go out there and I can draw that line on the, I can put a fence up. And the question is, for it to be, that fence to be truly on the border, part of that fence has to be on my property, and part of it has to be on my neighbor's property. So, if let's say my wall, I build a stone wall, and the stone wall is 2 feet wide. Well, 1 foot of that wall is on my side of the border, and 1 foot of that wall is on my neighbor's side of the border. And my neighbor may bitch and complain and say, well, I don't want that, and you're taking up my property. You're taking up 1 foot of my property with this 2 foot wide stone fence. Well, I can say, okay, let's make the fence only 4 inches wide. And that person could still complain, because if it's 4 inches wide, 2 inches on my side of the border, and 2 inches is on his side of the border between the two properties. That width of that border can get infinitesimally small. I could go down to millimeters, and still, I can't put something right on the border. If I put a 2 millimeter fence, that 1 millimeter would be on his property, and another millimeter would be on my property. So a border is essentially an imaginary line. Another example, what's the length of the coast of England? Well, that's a border. It's the border of land and water. So a coastline is actually a border. Now, if my unit of measure is 200 kilometers, well, approximating it, the length of the coast of England is 2,400 kilometers. If my unit of measure is 100 kilometers in length, and I draw 100 kilometer lengths around the border of England, the length of the coast of England is 2,800 kilometers. If I take the unit of measure down to 50 kilometers, then the length of the border is 3,400 kilometers. So the question is, well, what is the true length of the border of of the coastline, what is the length of the coastline of England? I could take that down to a millimeter, and that would be an incredibly large, lengthy coastal length. Like the length of the coast would be incredibly long. So I have to have some kind of approximation. I have to have like a real limit to what would be an accepted measure of the length of the coast. And the accepted measure of the length of the coast will be based on my unit of measure, whether it's 200 kilometers, 100 kilometers, 50 kilometers, or 1 kilometer. That's the type of abstraction we're dealing with real and apparent and real limits. So if I have a time for a continuous measure, like my measurement of how long it takes to run 400 meters, if I record on my stopwatch 50.4 seconds, that's the actual time. The real limits of that time are from 50.35 to 50.45. And that 50.35 is an imaginary border because I never actually hit it. My stopwatch, it just does not allow it to happen. And that's the concept we're dealing with real and apparent limits. Now, if I were to, and I'll do it in a bit, if I create a group frequency distribution, and if I say I want all the times between 50.0 and 54.9 seconds to be grouped together, my apparent limits are 50.0 to 54.9. But I have to look at the real limits, and I have to look at, well, what are the limits for 50.0? Well, 50.0 ranges from 49.95 up to 50.05. 54.9 borders from 54.85 up to 54.95. That's a tenth of a second. So the apparent limits are from 50.0 to 54.9. The real limits are 49.95 up to 54.95. If I look at the width of the limit, according to the apparent limits, my width would look to be 4.9 seconds. If I use the real limits, 54.95 minus 49.95, that difference is 5 seconds. So my real limits tell me my interval width, which is 5 seconds.